Hey, it's Mr. Kingsbury from your Algebra 2 class. Today we're talking about rational functions, specifically transformations of rational functions. Don't forget to put your period that you have me in today's date. Our essential question, and it's kind of a long one, is how do I identify the transformations that have been applied to the rational parent function given an equation, and how do I write an equation given some transformations? It's actually not as hard as you think. Now, at this point in the year, we've actually talked about transformations as they apply to several different functions, including absolute value and the quadratic family of functions. So we've looked at those and we've seen how they apply and all of that. So this should not come as much of a surprise. It should look very, very familiar to you. To begin with, let's look at the transformation equation. Transformation equation. Now, the rational function, actually, you know what? Before we look at the transformation equation, now that you've probably written that down, sorry about that, let's remind ourselves of a couple of things. Sorry, I started speaking other languages there for a second. First, let's identify this. Let's define this. Rational means that it can be represented as a fraction. So any number you can write as a fraction is considered rational. So of course that's all of the fractions. It includes decimals that repeat and go on forever, decimals that don't repeat, and integers as well. So all that stuff is in there. And because of that, that's going to make our equation look a little different. In fact, the parent function looks like this. Y equals 1 over x. And we're going to talk about the parent function in class. We'll do a whole thing on it, look at its graph, some of its values, its special stuff, whatever. There's something called asymptotes that are in there that we'll talk about. So that's all well and good. There we go. It was a little blurry. Sorry. Now it's better. Anyway, so from that then, we have the transformation equation. And that's going to look like this. Y equals A on top over x minus c on the bottom, and then plus d off to the side there. And just to remind you what each of these things stand for, A is our vertical stretch. It's also a vertical compression, but we're not going to do that this unit. We are not going to give you vertical compression at all. When you get an A value, it's just going to be a stretch. We're trying to keep it a little on the simple side because our time is limited. It would be fun to get into that and study it and so forth, but mostly we just have to touch on the subject and then we'll have to move on. Also, don't forget that this is a reflection over the x-axis. The c value moves us left and or right. And remember, the value of c has a different sign when it's in the equation than when we pull it out of the equation. What I mean is, if it looks like it's negative while it's in the equation, then it's really positive when you pull the value out. And you can't really interpret the value until you pull it out of the equation. And I'll show you how to do that. Not a big deal. And then the d is, of course, up and down. So let's tackle that first one with a couple of examples. Here's example 1. Let's say that I give you this equation, y equals 2 over x minus 5, and then we'll put a plus 1 on the end there. What I would do is identify what the a, B, and C values are. I'm sorry, I meant A, C, and D, not B. There is a B value. We're not going to look at it. So A is on top here. That would be 2. This would be 5. It looks like it's -5. But remember that the C value, it has a minus built in. So when you remove that minus, what's left is a +5. And then the D value is going to be +1. And then we can interpret each of those. Let's start at the bottom and work up because this is pretty easy. So D is up or down. Positive would be up. So this would be up 1. C is left and right. Positive would be right. So this would be right 5. And then lastly, A is both a vertical stretch and a reflection over the x-axis. Now, the vertical stretch has to do with the number. The reflection has to do with the sign. There's no negative sign, so there's no reflection. However, it is a 2, not a 1. It's different. So the 2 is going to be a vertical stretch by 2. And that's all there is to it. You have identified correctly all of the transformations there. Well, let's try another one just for fun. So let's do example 2. Let's go with y equals, how about -5 over x plus 2, and then we'll go -7. So again, I want to know what my A, C, and D values are. A is going to be -5. C is going to be -2. Remember I said it's all when you pull the C value out, you always change the sign. This is actually like saying x minus -2. Remember, there's a minus built in before the C. So if we rewrite this so that minus is there, what's left is -2. That's going to be my C value. And then my D value would be -7. And once again, I'll start at the bottom and work up. D is up and down. Negative means down. So this would be down 7. C means left and right. Negative would be left. So this means left 2. And then we have -5 for our A value. The 5 part means there's a vertical stretch by 5. The negative part means there's a reflection over the x-axis. And that's it. That's all we really need to do there. The other way, or the other thing we need to look at is going in reverse. That is, I'm going to give you the transformations, and you are going to tell me what the equation is that represents the parent function after we've applied those transformations. And I promise it's not as hard as you think. Remember, I gave you a transformation equation. So all we really have to do is figure out what A, C, and D are, and then substitute those values into the equation. Here's what I mean. Let's say that, for example 3, I say that the rational parent function has been moved left 3, up 5, and vertically stretched by 4. That's a good number. So for starters, I want to know what A, what C, and what D are. I'm not going to do anything else till I know what they are. So let's start with left 3. Left is a C value, and left would be negative. So my C value is going to be -3. Then we have up 5. So up and down is controlled by D. So I'm going to put the 5 stretch by 4. Vertical stretch is controlled by A. So I'll put my 4 there. And I don't have anything else to do. So it looks like I have my 3 values. Now there is not a reflection, so I don't have to worry about making this A value of 4 negative. However, I may have to in future examples. Hint, hint, nudge, nudge, wink, wink. We'll see what happens. Anyway, now that I have these, I can simply write out the transformation equation, which was this, and then plug everything in. So my A value is 4. I will replace the A on top with 4. I will write X, and I will write minus, and then my C value is -3. So I will replace that with negative 3. And then lastly, I have my d value of positive 5, so I will put positive 5 in there. Now, technically, you can leave it like this. There's nothing wrong with that. However, most mathematicians would not like the double negative here, and they would rather you write it as x plus 3 plus on the bottom there, and then put your plus 5 on the bottom. So you have something this would be the preferred answer. This is still completely 100% correct. Let me give you another one, and then we'll call it a day. So let's say that we wanted to instead go, let's say down 1, and let's vertically stretch this by 6. Let's go to the right 9, and let's reflect it. We'll say it was reflection over the x-axis. Once again, I need to know what A, C, and D are. And once again, I'm just going to start at the beginning and work to the end. So down is controlled by D. D is up and down. So I can put the 1 here, and then the question is it a positive 1 or a negative 1? Down means negative, so I'll make this negative. Then we have a vertical stretch by 6. That's controlled by A, so I will put 6 here. We will always look at our stretches with a positive number. We will come back and see if that needs to be changed negative if it says anything about a reflection. But for now, that's all we need on A. Then we have right 9. Now, left and right is controlled by C, so the 9 is going to go there. The question is it a positive 9 or a negative 9? Well, right is positive. You're going in the positive x direction, so 9 will remain positive. And then lastly, I have my reflection over the x-axis. This applies to the A value. The reflection means that the A value will be negative. So it turns out my A value is negative 6, my C value is 9, and my D value is negative 1. From here, I'm going to go back to the transformation equation, A over x minus C plus D, and I will substitute these things in. So negative 6 will go on top for A. And then I have x minus c on the bottom, so I'll put x in minus. My c is 9. And then I've got plus my d value. My d value is negative 1, so I'm going to put minus 1 there. And it doesn't look like I have anything to adjust, so that'll be my final answer. Some people would put plus negative 1. That's fine too. There's no big deal. You can do either of them. Most mathematicians like to just put minus because it's one symbol instead of two. Either way is perfectly acceptable. So that's all there really is to transformations. We will talk more about them in class. I've got a cool activity we're going to do, and then we'll practice. Speaking of class, I'll see you there. Bye.